Hello guys, welcome back to A-Level Business channel, and in this video we're going to look at chapter 54, decision trees, A-Level Business Edexcel. Okay, let's get started. So the learning objectives for this lesson are: construct and interpret simple decision tree diagrams, calculations and interpretations, and finally limitations of using decision trees. Okay, so let's get started then. So what are decision trees then? Well, a decision tree is a method of tracing the alternative outcomes of any decision. In this context, we're looking at business decisions, okay? So any business decision that you have to make, you're simply using a tool, which is a decision tree. You're using a diagram, it's a simple diagram, to work out what the outcome of that decision might be. Okay, what if that decision is successful? What if that decision leads to failure? What happens then? So that's your simple method of making decisions. Because in business, as I'm sure all of you know as business students, that in business you have to make decisions every day, and those decisions impact the overall profitability and success of a business. So it's crucial that you make the right decision, but also at the same time, when you do make a decision, it's always almost uncertain what's going to happen. So you don't know, you're always unsure of what the outcome will be. So we use a decision tree diagram to sort of manage the risk, to identify, to put a number at the outcome, to put a number, to give a quantitative value to an outcome of a decision. So okay, what are the chances that the decision might lead to success, and what are the chances that the decision might lead to failure? So it's sort of a method of quantitative risk management. So it's a quantitative risk analysis method, okay? And it's more effective than, simply having a meeting with your board of directors or whatever, or your management team, and sitting down and contemplating, oh, will this decision be successful? Will this decision lead to growth or profit or loss? Okay, so when you put a number to something, it's usually much more easy to convey and much more easier to analyze. Okay, so here is an example of a simple decision tree diagram, and the decision that we have to make is whether to retain an existing advertising campaign or begin a new one. Okay, so this is what a simple decision tree diagram looks like. Now, I'm pretty sure that in the A-level exam, they probably won't ask you to draw up a diagram. They probably won't ask you to construct a decision tree diagram because it's just too much hassle, and I don't think they've ever done that. They might ask you to fill it. Okay, they might leave this place blank, or they might leave this place blank, and they might actually ask you to actually complete a decision tree diagram, but they won't ask you to construct one from scratch. Okay, so this is what it looks like. It starts off with this little square box, and then you have two nodes coming out of it. These circle things are called nodes. So the square box indicates that there's a decision that needs to be made. So the square box is literally you're at the point where there's a decision that needs to be made, and you're not sure what to do. So the decision would be whether to retain an advertising campaign or begin a new one. Okay, and the nodes then, obviously, B and C, reflect the decision being made and what happens afterwards, after the decision's been made, obviously. Okay, so here the node B represents your decision to retain the existing advertising campaign, and node C represents your decision to begin a new one. Okay, so what are these numbers here then? Okay, this is what I was talking about earlier. This is the probability. So that is your probability. So 0.2, 0.8, 0.4, 0.6, these are your probabilities. Okay, so there is a 20% chance of retaining an existing advertising campaign decision of it being successful. So there's a 20% chance of this decision of retaining an existing campaign of being successful. So that would give you £15 million in profit. So that's your profit. And there's obviously 0.8, which is literally 80% chance of it being a failure. And that will incur you a loss of £2 million as a business. Okay, so this here is the probability. And if you don't, so go back to your GCSE maths days and try to remember what probability was. So probability, as I'm sure you all have probably learned, is a way of measuring or quantifying an outcome of an event that is about to happen. Okay, so clearly this decision hasn't been made yet, but what if it was? So it's about to be made. So what happens then? What will happen? What are the chances? So probability is simply a quantifying the chances of something happening. So there's an 80% chance that it's going to rain today. There's a 0.6% chance that it's going to be sunny tomorrow. Okay, or there's a 25% chance that it's going to snow next week. So it's the likely outcome of something, and you put a number to it, you quantify it. So that's what the probability is. And what you do in the decision diagram is you're trying to measure, trying to quantify your loss, your success, or your failure. Okay, so how would you quantify it then? So here's the probability. So you've got 0.2 chance, 20% chance of it happening, of it being successful, right? And it's gonna, if it becomes successful, it's gonna make you 15 million in profit. Okay, so all you have to do is you have to multiply them together to quantify the outcome. And if the decision of retaining an existing advertising campaign fails, then you have to quantify that loss. So this 0.8 times £2 million minus £2 million, will give you your loss in numbers. Okay, so and we're doing the exact same thing with the other decision, and it would look like this. Okay, so here we go. You have the quantified value of the success, which is 3 million, and the quantified value of the loss or the failure, which is minus 1.6 million pounds. Then what you do is you work out the expected monetary value. Now, what is the expected monetary value? That is your total, your overall profit or loss. Okay, that is your total value of success and failure added together. So you add the success and the failure. So obviously, clearly it's minus because it's minus 1.6, and then you get your expected monetary value. Okay, and once you get that number, you're done. You move on to the next node, the next decision, and then you simply do the same thing, 0.4 times 7 million, the probability times the actual profit or loss, and then you add together the outcomes, which gives you the overall outcome or the expected monetary value, and then you simply check which monetary value is higher. Now, obviously, with this example, node C gives you a higher expected monetary value, which means it's better for you. So you should go with decision C, which was to begin a new campaign. So here's your decision, and you can take it, and you know that the expected monetary value of this decision will be potentially higher than the decision that you would have made if you decided to go with the existing campaign. Okay, so that's pretty much it for the decision tree. There's nothing else to do in decision tree diagram or this chapter, to be honest. I'm just going to finally end with some advantages of decision trees. So constructing the tree diagram will show you the possible courses of action not previously considered. Numerical values will give you a clearer picture, and also it's pretty easy to do. Disadvantages: overfitting, so they might become too complex and fail to generalize new data. So I'll show you an example of this, how this can happen, because this can happen if your decision tree becomes too complicated or too complex. But right now this is really fairly simple, but this is just an example. But if you do it realistically, it's much more complex, so it might become overfitting. It might not make any sense. When you've got an overload of information, then it just doesn't make sense. So unstable: small changes in data can lead to significant changes in the structure of a decision tree. So again, if it gets complex, then it's obviously not very efficient, right? Biased: okay, it can be biased towards the dominant class in classification. And finally, decision trees may struggle with difficult and non-linear relationships. Again, some things, it's just a really fairly simple probability calculation, so it might not cover the the non-linear relationships of decisions, right? Okay, so as promised, I'm going to show you the decision trees, typical examples of decision trees. Let me show you. Oh, okay, here you go. That's another example of decision trees. Okay, that looks pretty much the same as what we had in our example in the PowerPoint, but let me show you a more complex one, which I had opened up for you. Yes, this one. So this was another example of a decision tree. So here's another example for decision tree. As you can see, it doesn't look exactly like the one we actually saw in our PowerPoint, but this is a decision tree nonetheless. As you can see, they have a square box and they have different decisions. So build new app, upgrade the existing app, productivity team, okay? And then these nodes represent these decisions. So as you can see, there's more than one decision here. There's plenty more. There's lots of other decision tree diagrams which are much more complex than this, but I think just to understand the concept, you don't really need to look at the complicated decision tree diagrams, because in A-level business, I think they will probably give you, the most that they can give you is three nodes at a time. So they'll either give you 2 or 3. You might have another node here which says do nothing, or you might have a node that gives you another decision needs to be made. They might give you a decision tree diagram that's already there, and you just might have to fill it up. Okay, this might be blank, so if it's 0.8, then you just have to put 0.2, because probability. So if the probability of an event happening, if it's certain, okay, you are sure 100%, then it adds up to 1. So probability always adds up to 1. Okay, so you obviously know that if it's 0.2 here, then this will be 0.8, and if it's 0.6, that will be 0.4. So that's the diagram. That is literally the most that they will ask you to do in an exam, and it's literally really simple, fairly easy to do, fairly easy to read once you understand. It's nothing, it's just multiplying the probabilities and then adding together the profits and losses, which will give you the expected monetary value, and whichever one is higher, you choose that and you go with that. Sometimes they don't even ask you to do all of that. That's just too much calculation. They simply ask you to fill the diagram, and sometimes they ask you to do both. So these are fairly easy marks to actually get in the exam. So I hope this video was hopefully helpful and it made sense. If you still have more questions, you can obviously comment them down below. But yeah, overall, this chapter is done. Thank you so much for watching this video, and please subscribe and share the video if you think it was helpful and it might help some of your other friends or other people. Thank you.